Okay, so at this particular station, we are displaying on semiconductors, module and discrete solutions for onboard charger. Also applies for DC-DC as well. In some cases, the onboard charger is integrated with the DC-DC. In some cases, it is not. What is really being featured here for the module solutions is a selection of modules that we offer to the industry. One of the big advantages to the modules is that they are electrically isolated. So this surface here is actually a DVC. It is electrically isolated from the active devices. That means that these devices can be either silver sintered to a board, very, very good thermal resistance, very similar to what you would see in the traction modules. And then if you didn't want to go with the expense of a silver sintering process, you could actually also do a very thin layer of thermal grease. If you go with a discrete solution, it's a little bit different situation. Those devices, the pad would be electrically active, and that would be electrically active at high voltage. And so a little bit more work is going to need to be done there to isolate it from the heat sinking system. Keep in mind, you can't see it here, but back here in the back of the module are the liquid cooling system inlet and output. So this always will have access to the car's liquid cooling system. That's a really good thing, but that means you have to have good thermal performance to that liquid cooling system. The better, more power you can run. This is a 22 kilowatt right here. Okay. Substantial power going into the vehicle. So if you go with a discrete solution, you'd have to go with a layer of TIM. Let's hope that TIM doesn't have any voids in it. Or you could go with alumina and TIM, but you're incurring a little bit more expense, and you're also incurring more thermal resistance. So while we do see a lot of customers adopting a more straightforward and simple discrete approach, you can make the module system more efficient and smaller and lighter weight. Given that, you also have the potential, even though the modules are a little bit more expensive, to make the overall system cheaper. So there are advantages to going the module route. Okay. Also at this station, we're featuring our M3S technology. It is important to keep in mind that up till M3, everything was traction-centric. So everything was built around a good capability for short circuit, which doesn't matter in the OBC. It's not necessary. However, that means more gate charge and slower switching capability. M3S is designed for high-speed switching. It's designed for OBCs. And so it's an excellent option for the down converter where customers would like to go at least 250 kilohertz typically. We're seeing customers want to go 350 kilohertz on the down converter. M3S is an ideal option for that. And another reason why M3S is only packaged in packages that offer Kelvin sense, because you're not going to get there without the incorporation of Kelvin sense. So these could be used on the onboard charger. There are different topologies in the modules. So there's two ways to go. There are standard options. We have Vienna rectifier. So in this module, you have a primary and a secondary. The primary is the PFC. The secondary is the down converter. This particular one is unidirectional. It could be bidirectional. The topology that you would pick, like if you were unidirectional, you might go with a Vienna rectifier on the primary. We have a Vienna rectifier already packaged. On the down converter side, you can go with a dual active bridge. You can go with a CLLC. We offer dual half bridges. We offer full bridges. We offer a variety of pre-made modules that can support those options. Or again, on the down converter, if there is a business case, we can custom build, and we do that.